All right, let's talk about the least squared estimators for the simple linear regression model. So remember, the simple linear regression model is yi equals beta 0 plus beta 1 times xi plus epsilon sub I. And so what we're talking about right now is how do we estimate this beta 0 and this beta 1, okay? So remember, if we have data, so let's draw out our data. Okay, here's y and here's x. And so we have observed values of x and y, right? They are a scatter of dots. They don't line up exactly on a line, but they're around, you see some sort of, in this case, I have some sort of positive correlation, okay? Now, the regression model, what we want it to do is to go through these points, and we want it to minimize the distance between each of our observed points and the line. So this distance I'm marking here in red, we want this distance to be minimized. Okay? So this distance marked here in red, that's called the residual. Okay? So this line, this blue line is the fitted line, y hat is the fitted observation, and the equation for y hat is b0 plus b1 times xi, okay, where b0 is the least squares estimator of beta 0, and b1 is the least squares estimator of beta 1. Okay? So this distance in red is E sub I. This is going to be the difference between, so in yellow I have the ith observation, and on the line I have the predicted ith observation. Okay, so this error is the difference between the observed ith observation minus the predicted ith observation. Okay, and that's called the residual, right? So E is the residual, and there's a different residual for every observation, right? And what we want to do is we want to minimize those residuals. And we don't care if the residual is positive or negative. So if the residual is below, if the observed value is below the predicted line or above the predicted line, right? So since we don't care about the direction, but we just care about minimizing that distance, what we're going to do is we're going to minimize the square of the residuals. So you see that least squared estimators has to do with the fact that we're squaring these residuals, okay? And you could have, taken the absolute value, and you would have a different type of estimator, okay? So there are different estimators for sure. The least squared estimator has some really nice properties, which is why we like to use it, okay? But the idea behind the squaring of the residual is to get rid of the sign, okay? So what we're going to talk about now is we want to minimize the residual sum of squares. All right, and what that means is that we want to find the min of the sum from I equals 1 to n of E sub I squared. Okay, and I could rewrite this, actually let me go ahead and write this as the min of the sum of I equals 1 to n of yi minus yi hat squared, right? That is what the residual is. It is yi minus y hat squared, right? So this is the same thing as minimizing yi minus b, actually let me use parentheses, another set of parentheses, b0 plus b1 x sub I. Okay, all I've done is I've plugged in the predicted formula, right? Okay, to minimize this equation, what I need to do is I need to basically find the partial derivative with respect to beta, or respect to b0 and with respect to b1, and set it equal to 0, right? That's how you find the minimum. You're going to find the derivative and set it equal to 0. All right, so starting with, well, actually, before we do that, using the centered model, which I talked about in a previous video, the centered model will make finding these derivatives a lot easier. And so I do want to use the centered model. Now, if you remember, the centered model uses beta 0 star equals beta 0 plus beta 1 times x bar. Well, you can do the same thing. Instead of it being beta, you can do b. Okay, so b star equals b 0 plus b1 times x bar. Okay, so this is our centered model formulation. And so we have, instead of having the different betas, we have y I hat equals, instead of having beta, we have b. So b star plus b1 times x sub I minus x bar. Okay, and so we're going to plug this in instead. So when I say I want to minimize, this is the same thing as equal to the min of yi minus b naught star. Okay, I'm going to go and distribute that minus sign, so I have minus b1 x sub I minus x bar squared. Okay, so I've plugged this guy in instead. Okay, all right, so now when I'm taking my derivative, instead of taking the derivative with regard to b, or b naught, I'm going to take the derivative with regard to b naught star. All right, so let's go ahead and start this by, let's go ahead and find this derivative. So the derivative, partial derivative with respect to b naught star, right, of this sum, yi minus b naught star minus b1 x sub I minus x bar squared, and setting it equal to 0. Okay. Now, to find the derivative of this, so basically let's use our chain rule. So basically bring down the 2. Minus b1 x sub I minus x bar, and then take the derivative of the inside with regards to b naught. I still have this sum out front. Okay, so take the derivative of the inside with regards to b naught. Okay, this is a constant. The derivative of this one with regards to b naught is just -1. So times -1, and then there's no b naught back here, so this is a constant. Okay. All right, you can divide both sides of this equation by -2, right, which basically will get rid of this guy. So I'm left with yi minus b naught star minus b1 xi minus b, or x star, or x bar. Okay. Okay, so this is the sum of all of this. So now to solve this, let's go ahead and bring our sum into each part. So we have the sum from y equals 1 to n of yi minus the sum from y equals 1 to n of b naught star minus, I can pull out this b1 from the sum since it doesn't depend on I, of x sub I minus x bar, okay, equals 0. Okay, so this sum of y, let me have the sum from I equals 1 to n of yi, okay? And then we have this sum, there's no I here, right? There's no I here. So if you sum the same number up n times, you're just going to get n times it, right? And then back here, all right, let's talk about this for a second. The sum of x sub I minus x bar. Now, if I were to, let's go ahead and do this. So I have y equals 1 to n of x sub I minus the sum I equals 1 to n of x bar. And once again, when you sum something n times, you get itself. So it'll be n times x bar. Right? Now, what is x bar? X bar is the sum of x sub I from I equals 1 to n divided by n. Right? So these n's cancel, and you're left with the sum of xi minus the sum of xi, which is 0. Right? So basically this back piece back here, it is 0. All right? Okay, so what am I left with now? I have the sum from I equals 1 to n of yi minus n times b naught star equals 0. Okay? So this is of y sub I. If I add on n times b naught to both sides, I get n. Okay, just doing algebra now. Okay, and what do I have? The sum, divide both sides by n. Okay, and that is y bar basically. All right, so the least squares estimator of beta star is y bar. Okay, we're not usually interested in knowing the estimator for beta naught star. Rather, we want to know the estimator for beta naught. So remember, so b naught star is equal to b naught plus b1 times x bar. Okay, so in other words, if I were to rearrange this, I would have b naught equals b naught star minus b1 x bar. Okay, so if I were to plug in my estimator for beta or b naught star, which is y bar, okay, I get my estimator for b naught, for beta naught. Okay. Now notice it does depend on the estimator for beta 1, which is b1. So let's find that next. That's the next thing that we need to find. Okay. So I need to go back and I need to figure out the partial derivative with regards to b1 of this sum of yi minus b naught star minus b1 x sub I minus x bar, okay, squared, and set it equal to 0. So now I'm taking the partial derivative with respect to b1 instead of being with respect to b naught star. All right. So once again, use your chain rule. Bring the 2 down. So we have 2. I still have the sum out front. yi minus b naught star minus b x sub I minus x bar, okay, times the derivative of the inside these parentheses with regards to b1, okay, so this with regards to b1 is 0, with regards to b1 is 0, and then the derivative of this last piece with regards to b1 is just this x sub I minus x bar, okay. Okay, so now let's go ahead and solve this by, first thing I want to do is go ahead and distribute this piece in. Okay, and when I do that, well, I can also divide both sides by 2 and get rid of that 2 out front as well. So when I distribute, I'll have this sum of yi times xi minus x bar minus b naught star times xi minus x bar minus b1 xi minus x bar squared. You set that equal to 0. Okay. Each of these are being summed, so let's go ahead and distribute that sum of yi xi minus x bar minus, this doesn't involve I, so it can be pulled out of the sum. Okay, and again, b1 doesn't involve I. Okay, and set equal to 0. Okay, so we just talked about when you do this sum, you get 0, so that's the zeros out. So what we're left with is this sum from I equals 1 to n of yi times xi minus x bar, okay, that middle piece disappears, minus b times the sum of xi minus x bar squared. Alright? Alright, so now if I do a little algebra to get b1 by itself, right, bring it over to the other side of the equation. Okay, and then solve for b1. Alright, I get my formula for the estimator of beta 1. Now, this is the same thing as yi minus x, or y bar times xi minus x bar divided by okay. These are the same thing, and you can show that this is the same thing as this relatively easily. You would distribute, well, the other way around. You would distribute yi times this guy, and then y bar times this guy, and then because y bar doesn't involve I, basically it zeroes out, and you end up with these guys being equivalent to each other. Okay, and I'll save that for something for you to do on your own. But the reason why it's nice to write it like the second way I wrote it down here is because we have this notation, S, Y, X divided by S, X, X. Okay, and S, Y, X is basically, it's what you're seeing here. We have yi minus y bar, so centered y values, times, so it's a sum of centered y values times the sum of centered x values. okay? And then divided by SXX is the sum of centered x values times the sum of centered x values, so, or them squared by each other, okay? So this is what B1 equals. So just a reminder, so this is B1, and B0 was y bar minus B1 times x bar. So these are my two least squared estimators, which have some really nice properties, which we'll go through in the next few videos, regarding their the value of their expected values and their variances.